students, let us discuss about the product of two vectors. In the last chapter, addition of vectors, we came to know that how to multiply a scalar with a vector. That is called scalar multiplication of a vector. In this chapter, let us discuss about how to multiply any two vectors. Product of vectors. You can multiply two vectors or three vectors, let it be any number of vectors. There are two ways. One is dot product, other one is what? Vector product. Now, let us confine our attention how to take the what? Product of two vectors, only for two vectors. Now, first one is product of vectors. First one is, in this product of vectors, there are two types of vectors. One is scalar or dot product. Dot product of two vectors. Now the second one is vector or cross product of two vectors. Now, we shall discuss about scalar or a dot product. I take, let OA bar is equal to A bar, OB bar is equal to B bar. This is theta. Let OA bar is equal to A bar, OB bar is equal to B bar, be two non-zero vectors, and theta be an angle between them. Then the dot or scalar product of any two vectors, A bar and B bar, is defined as mod A into mod B into cos theta. Mod A is a scalar, mod B is also scalar, cos theta is a what? Angle between the two vectors. It's a convention we made. If you measure the angle between A bar and B bar is what? Theta, in terms of cosine of the function, then this product we call it as what? Dot product or a scalar product. Why scalar? This also scalar, this also scalar, this also scalar. In particular, if I take theta is equal to 30, cos 30 is what? Root 3 by 2. 60, cos 60 is what? 1 by 2. So therefore, all this 1 by 2, root 3 by 2, 1 or 0, all these are nothing but a scalars, a real number. So therefore, total value is a real number. So therefore, when it is a real number, when it is a scalar, for that this product we call it as what? Scalar or dot product, and is denoted by A bar dot B bar. Therefore, A bar dot B bar is equal to mod A mod B into cos theta. A bar dot B bar is equal to mod A bar into mod B bar into cos theta. This is called dot or a scalar product. So therefore, when LHS is what? Scalar, RHS is also scalar. Therefore, LHS is equal to RHS. So therefore, now A dot B is equal to mod A into mod B into cos theta means the dot or a what? A scalar product of two vectors is always a scalar. It is not at all a vector. Okay. So therefore, now the note 1 follows. What's the note 1? In A bar dot B bar, in this product, we call it as A bar as a pre-vector and B bar as a post-vector. Now, in A bar dot B bar product, the vector A bar is called pre-vector and the vector B bar is called post-vector. Post-vector. Next, note 2. The dot or scalar product of A bar comma B bar is a scalar quantity. Third one is if A bar dot B bar is equal to 0, which implies A bar is equal to 0 or B bar is equal to 0 or A dot B is equal to 0. Means which implies A bar comma B bar are null vectors if A dot B is equal to 0 means, which implies are perpendicular vectors. Why? Theta is equal to what? A bar dot B bar is equal to 0 means theta must be equal to 90. Why, sir? If I take A bar dot B bar, this is nothing but mod A mod B into cos 90. What is cos 90? 0. This is what? Non-zero quantity. This is 0. So, therefore, which implies A bar dot B bar is equal to what? 0. So, wherever you come across A bar dot B bar is equal to 0, then A bar and B bar are perpendicular vectors, or else we can also call them as orthogonal vectors. So, which implies A bar comma B bar are perpendicular vectors orthogonal vectors. So, therefore, after knowing the word common perpendicularity, then let us see the other concept. The angle between two vectors A bar comma B bar is theta. This is minus A bar minus B bar. Okay, this is 180 minus theta. This is 180 minus theta. This also same. 180 minus theta means angle between A bar comma B bar is equal to this also theta minus A bar comma B bar is equal to theta. Angle between minus A bar comma B is same as A comma minus B bar is equal to 180 minus theta. Now, if theta is equal to 90, look at, if the angle between the two vectors is theta, if theta is equal to 90, then they are perpendicular. Case 1, if 0 less than or equal to theta less than 90, then which implies A bar dot B bar is greater than 0. Why, sir? We know already A bar dot B bar is equal to mod A into mod B into cos theta. This is positive, positive, cos 90. When theta lies between 0 and 90, it's an acute angle. Whenever any two vectors involve an acute angle between them, then always A bar dot B bar is greater than 0. A dot B is equal to mod A into mod B into cos theta. Theta is what runs from 0 to 90. It's an acute angle in first quadrant. Cos is what? Positive. So therefore, this also positive, this also positive, total value is positive. Therefore, A dot B is greater than 0, remember. Now if I go for, this is the first one. The second one, if theta is equal to 90, A bar dot B bar is equal to 0, then they are perpendicular or orthogonal. Next, the third one is, if 90 less than theta less than 180, more than 90, it's an obtuse angle. In the second and third, it's a what? Theta is what? Cos theta is what? Negative. Means it's an obtuse angle, which implies A bar dot B bar is less than 0. How come? A dot B is equal to mod A, mod B, cos theta. Positive, positive, cos is negative. Therefore, A dot B is less than 0. So, hereafter, the angle between the two vectors A bar and B bar is acute. Then you are able to take A dot B greater than 0. If theta is equal to 90, then A bar dot B bar is equal to 0. Means they are perpendicular. If theta lies between 90 and 180, therefore it includes an obtuse angle. We can write A bar dot B bar as what? Less than 0. A bar dot B bar is less than 0. Right. If K is a non-zero scalar, and A bar is a non-zero vector, then Ka bar, it's a scalar multiplication of a vector. So what I want to know is, if it is a scalar multiplication of a vector, then it is defined. If I put a what? Dot, it is not defined. Why? Because what's the definition says? The definition says the dot product of two vectors or scalar product of two vectors. You are defining the what? Dot product only between the two vectors, not between a scalar and a vector. So therefore, K dot A bar is not defined. So therefore, A is not defined. Next notice, let A bar comma B bar comma C bar, it's a non-zero scalar, B3 non-zero vectors non-zero vectors, then A bar dot B bar dot C bar is not defined. Why, sir? I told the scalar product or dot product of any two vectors is a scalar quantity. It is not a vector quantity. Because of that reason, A dot B bar, A bar dot B bar has become a scalar. As I told K, it has become scalar. Can you take a dot product with the C bar with the scalar? No, it's a meaningless. Therefore, A bar dot B bar dot C bar means the dot or a scalar product of three vectors is not at all defined. I mean, in particular, the dot or a scalar product is defined only for two vectors. So therefore, now it is not defined. Next I go to what common? Note. The note is A bar dot A bar is equal to mod A into mod A into cos 0. If I take this is one line, the angle made by the line with the same line is always a 0 degrees. So therefore, now A dot A, it's a very, very good advantage. This property seems to be very silly and simple, but it is having its own applications throughout the vector algebra. Where not you find? Everywhere you can find out. So therefore, A bar dot A bar is equal to mod A bar cos 0 degrees. Cos 0 is how much? 1. So therefore, I can write mod A into mod A. So therefore, A dot A is equal to mod A whole square is equal to A square. So therefore, remember hereafter A dot A is equal to mod A whole square is equal to what? A bar square. If, next note, if theta is equal to 0, 0 is the angle between the two vectors. Theta is equal to 0 between A bar comma B bar. Then A bar dot B bar is equal to mod A bar mod B bar into cos 0. Therefore, I can write A bar dot B bar is equal to mod A into mod B. Whenever, wherever you come across A bar dot B bar is equal to mod A into mod B, then A bar and B bar either must be collinear or what? Parallel. Then only the angle between them is what? 0 degrees. Now, next note is if the angle between A bar and B bar is what? Theta is equal to 180 degrees, since cos 180 is equal to how much? Minus 1. Then A bar dot B bar is equal to mod A mod B into cos pi or cos 180. A bar dot B bar is equal to A bar B bar. This is minus 1. Therefore, A bar dot B bar is equal to minus A into minus B. Means whenever, wherever you come across a bar dot b bar is equal to minus a bar into minus b bar, or minus modulus of a bar into modulus of b bar, nevertheless it represents, they are collinear but opposite in direction. Why? If I take what's the angle in the straight line is 180 degrees. They are unlike vectors because 180 degrees. Yes. Next note comes about for the perpendicular unit vectors, that is vectors I, j, k. I can write first one is I dot j is equal to 0, j dot k is equal to 0, k dot I is equal to 0. Now if I take this is O, this is Y, Z axis. Now you take I, J, you take K. Always x axis denoted with what? I, next J, next K. They are orthonormal right-handed system of vectors. We know that the angle between x and y axis is 90 degrees. Suddenly, the angle between I and j is also 90 degrees. It is quite obvious to say about the angle between y and z and x is also 90 degrees. Therefore, let us see how this is 0. I dot j mod I mod j into cos 90. Angle between x and y axis is what? 90 degrees. Therefore, this becomes total 0. Similarly, I can also write j dot I, this is j dot k, this is also k into cos 90 is equal to 0. Next, k dot I is equal to modulus of k, modulus of this is cos 90 is also 0. So, therefore, hereafter, whenever, wherever you come across the perpendicular unit vectors, I dot I is equal to 1, j dot j is, I dot j is equal to 0, k dot j dot k is equal to 0, k dot I is equal to 0. And next I go for I dot I. The second one is I dot I is equal to 1 is equal to j dot j is equal to k dot a. How? Let us see. Now, what is the angle made by the x-axis with x-axis? 0 degrees. Y-axis with y-axis, 0 degrees. Z-axis with z-axis, 0 degrees. Followed? So, therefore, now what I write is, now, I dot I modulus of I into cos 0. This is also 1, this is also 1, it's also 1. So, therefore, I dot I is equal to 1. In the same fashion, j dot j is equal to 1 is equal to k dot k. So, therefore, hereafter, I dot j is equal to 0, j dot k is equal to 0, k dot I is equal to 0. I dot I 1, j dot j 1, k dot k 1. Let us see. Hereafter, we have to give the what? The geometrical treatment for every definition. Because you get more geometrical applications on each and every vector's concept. Now, I take OA bar is equal to A bar. OB bar is equal to what? B bar. I start. The proof of this one is, let OA bar is equal to A bar, OB bar is equal to B bar, be two vectors and angle between the two vectors A bar comma B bar is what? Theta degrees. Now you take this is theta. Now after this, draw the line perpendicular to OA. Draw the line MB perpendicular to OA. Now perpendicular to OA. Now OM is a sublength. Entire OA is equal to A bar. But OM is not a outcome on A bar. OM is when OA bar is equal to, modulus of OA bar is equal to A bar. Modulus of OM bar is not a modulus of A bar. Of course, this may be collinear with this, correct? What I do is, I want to find out OM. This OM is nothing but a length along OA. Later, the length of OM, I call it as projection of B bar on A bar. So therefore, now what I do is, from triangle OBM, what is cos theta ray? OM by OB. So right, this OM is called what? Length. This we call it as projection. But what is modulus of OA bar? Modulus of A bar. Modulus of B bar. Modulus of B bar. So therefore, I can write OM is equal to mod B into cos theta. Means here theta is an acute. Theta is an acute. Projection is positive. Projection is positive. Now you call this as result number 1. Okay, result number 1. So therefore, now what I do is, by definition, A bar dot B bar is equal to mod A bar into mod B bar into cos theta. A bar dot B bar is equal to mod A into mod B into what? Cos theta. So, but here I can write what is common here. What is this one? A bar dot B bar mod A into OM from 1. Here I want to substitute. This OM is nothing but projection or scalar projection of B bar on A bar. Projection of B bar on A bar is equal to A dot B by modulus of A. Similarly, I can also write, look here, similarly, the projection of, look here, projection of A bar on B bar, B on A, I have taken B bar here, A bar here, instead of B bar, if I take A bar, if I take B bar, now this I can write it as projection of A on B is nothing but A dot B by modulus of B. Students, by the definition of the geometrical interpretation, or by geometrical interpretation, we could prove the projection formulas for the definition of dot or a scalar product. How do you think, how do you argue, how do you interpret geometrically the dot product is, it's a projection of B bar on A bar, A dot B by modulus of A, on A bar in the denominator A bar, on B bar in the denominator what? Modulus of B bar. Followed? So therefore, hereafter the projection or scalar projection of B on A dot B by modulus of A, scalar projection of B on A on B is what? A dot B by modulus of B. Modulus of B. So therefore, now I can very well observe. Now, if theta is positive, if theta is acute, projection is positive. If theta is obtuse, projection is what? Negative. If theta is equal to 90, projection is equal to what? 0. Followed? That's right. Okay. Yes, now look here. Just now we come across about OA bar is equal to A bar, OB bar is equal to B bar. Now, if I take this is what? B bar. Yes, case 1, we came to know that OM is equal to mod B into cos theta is called projection of B bar on A bar. Case 1, if theta is acute, means here I have taken acute angle as I drawn in the previous. This is theta is acute. It can vary from what? 0 to 90. Then OM is equal to mod B into cos theta is mod B into cos theta is a positive, So therefore, now OM is called projection of B bar on A bar or component of B bar along A bar. Component of B bar on A bar. Case 2. If theta is obtuse, then OM is equal to mod B into cos theta is negative. Therefore, OM is called projection of BR, and this one is. If theta is equal to, theta is a right angle right angle. Then the projection of B bar on A bar is equal to 0 is equal to OM. OM is equal to 0. Remember, as I told from the geometrical interpretation of dot product, theta is the angle between A bar and B bar. This length OM is called projection of B bar on A bar or A bar on B bar, or sometimes in some books says component of B bar along A bar. Both are same. So now coming this one is, since mod, that is OM is equal to mod B into cos theta, we have proved already, is called projection of B bar on A bar. Case 1, if theta is acute, the projection is positive. If theta is obtuse, the projection is what? Negative. If theta is right angle, then the projection is what? 0. Projection is 0. Right. Now let us discuss about orthogonal projection. Let A bar comma B bar be two vectors such that C comma D be 2 points on the vector B bar, P comma Q be 2 points on the vector A bar. Draw perpendiculars. Perpendiculars from C comma D to P comma Q respectively. Like this. Then PQ is called orthogonal. Projection of B bar on A bar. If you want, you can take, let OA bar is equal to A bar, OB bar is equal to B bar, as you please. So therefore, A bar be the vector, B bar be the second vector. Now if I take this as OA, if I take this as what? OB, on these two lines, select the 2 points here, C comma D and P comma Q. Draw a perpendicular lines from C comma D to this line. Then this length PQ is called what? Orthogonal projection of B bar on A bar. Orthogonal projection of B bar on A bar. Let us see what is the formula to find out the orthogonal projection. Right. The concept says the component vector of a vector R bar along A bar is equal to R bar dot A bar whole square into A bar. This is first one. The component vector of a vector R bar perpendicular to A bar is same as orthogonal projection of R bar along A bar. This is given to be R bar minus A bar R bar dot A bar modulus of A bar whole square into A bar. Followed? So therefore, now we have to prove that. Let us see. Now if I go to this one is, you take OP R bar, OA is equal to A bar. This is O theta. Right. And this is the length. Right. Now I start. The proof of this one is, let OA bar is equal to A bar, OP bar is equal to R bar, be two vectors and angle between them is what? Theta. So therefore, angle between them is theta. Now, draw PM perpendicular to OA. This OM is called length. Length is nothing but a projection. As I told from the geometrical interpretation of a what? Dot product. OM is nothing but a length. Length is nothing but a projection. And projection of what? Projection of B bar on A bar. Followed? So therefore, now what I do is perpendicular to OA. So now what I do is OM, I start like this. What is OM? OM is nothing but projection of R bar on A bar. This is the length. So therefore, I can write by using the geometrical interpretation of dot product, the projection of B on A in the denominator you must have A dot B by modulus of A. In the same fashion, R bar dot A bar by modulus of A bar. But this is a length. I want the component vector of a vector R bar along A bar. This is the vector along A bar. Means this OM you have to convert it as a vector which is collinear with A bar. Followed? Which is collinear with what? A bar. So therefore, now any length can be converted into a what? Vector if you multiply both sides with what? Unit vector, or else the unit vector in the direction of A bar. So therefore, I can write OM bar is nothing but, now it's a unit vector in the direction of A bar. Which implies OM bar is equal to component vector of a vector R bar along A bar is equal to R bar dot A bar by modulus of A bar whole square into A bar by modulus of A bar. This is nothing but R bar dot, this is whole square is not there. Now this is mod A into mod whole square into what? A bar. This is scalar, it's a vector. Now scalar projection of B on A dot B by modulus of A. This also a projection, but it is vector quantity. So therefore next, now OM I got it, the component vector of a vector R bar along A bar. Along A bar is OM and OM only, that I have to find out. I found out. Next, the component vector of a vector R bar perpendicular to A bar means MP bar. Now what I do is by vector addition. By vector addition, MP bar is equal to MO bar plus OP bar I wrote my vector addition. The terminal point of the first vector must coincide with the initial point of the second vector. We don't have MO, we have OM bar. That's what we found out. Now change the direction. What is OP bar? OP bar is nothing but R bar. OM bar we found out already. R bar dot A bar by modulus of A bar whole square into A bar. This is nothing but what? The component vector of a vector R bar perpendicular to A bar. The component vector of a vector R bar, this is the component perpendicular to A bar along. Okay. This is same as the orthogonal projection of R bar along A bar. R bar along A bar. Hence, we got it. MP bar is equal to R bar minus R bar dot A bar by modulus of A bar whole square into what? A bar. This is called orthogonal projection. Is known as orthogonal projection. Friends, again you see, let OA bar is equal to A bar, OP bar is equal to R bar. Be two vectors, theta is angle between them. So therefore, then draw PM perpendicular to OA. OM is equal to projection of R bar on A bar, R bar dot A by modulus of A. But OM is the what? Length. I want to convert it as a vector, multiply both sides with what? Unit vector. I mean the unit vector in the direction of A bar. Yes, this is called component vector of a vector R bar along A bar. Next I want, that is component vector of vector r bar perpendicular to a bar is mp bar. By using vector addition mo plus op, then you substitute. This gives the what? Orthogonal projection or component vector of a vector r bar perpendicular to a bar. Thank you.